The views expressed on Skeptically Speaking do not necessarily reflect the opinions of the University of Alberta, the Students' Union, or CJSR.
Hello and welcome to Skeptically Speaking, a show that asks you to call in and question everything. My name is Michael Harrison, filling in for our regular host Desiree Schell, who is currently in North Carolina, speaking on a panel about trust and critical thinking for Science Online 2010. So, global climate change is, in my humble opinion, the most important issue of my lifetime. The predictions range from mundane to terrifying, and no one seems to know what to do about it or how. Now, I've seen documentaries that claim one thing or another, from An Inconvenient Truth to the Great Global Warming Swindle. And I've read the articles and the blogs, and I've listened to the podcasts and the broadcasts, but it's still an issue I have a hard time getting my head around. So it's pretty fortunate that today we have John Gamon, professor at the Earth and Atmospheric Sciences Department at the University of Alberta, to talk to me about it. But before we get into that, let's start with the speaking up. Today we have Della Drury in studio, who is going to talk to us about dinosaur vocalization, a.k.a. what did dinosaurs sound like? Hello, Della.
Hello.
So I've seen Jurassic Park, the documentaries, all three of them, and that sort of led me to believe that the matter had already been settled. I mean, they make the roaring sounds and all that.
Well, even though they make up these sounds for the dinosaurs to sound very dramatic on screen, they actually don't know at all what dinosaurs sounded like. We can speculate all we want, and we can calculate all we want, but we'll never know for sure what their sounds were. They could have made chirps, they could have made bellows, they could have made those roars, but they don't actually have any data about how they produced them, other than their airways. Right now they're doing some great research with T-Rex skulls, looking at their air chambers within it, looking at how that might influence their vocalizations. But I don't know anything about that, so we're not going to talk about that. We're going to talk about hadrosaurs. Hadrosaurs are also known as duckbill dinosaurs, and there are two basic types of duckbill dinosaurs. There's the ones with crests and ones without crests. And again, we're going to not look at the ones without crests because I don't know anything about them.
That seems fair then. All right.
So we're going to talk about the ones with crests. The crests themselves were just elaborate looping nasal passages. Their noses were just encased in their skulls and looping way back around and all over the place.
Really? So there was I've seen some of these dinosaurs, and so they have that large projection that comes out of their head, and there's a nasal passage weaving all the way through that? That's how that works? Okay.
Yeah, so the nose starts on the front of the face, just like us, but rather than going directly into the lungs, like ours do down the throat, it loops past your forehead and perhaps a few loops above it, beyond the back of your head, and then back down into your throat and into your lungs. But that's how they have their noses, not us.
Yes, I think that would be pretty long then. Do you have a couple meters?
Yeah, a couple of meters on some of the larger hadrosaurs, Parasaurolophus, if I'm pronouncing it correctly. I always get that wrong.
I'll take your word for it.
But basically what you do with those nasal passages is you can measure them for their width, for their length, for their proximity to other air chambers, and then figure out what kind of frequencies they could produce. That's the closest thing to knowing how they sounded that we can actually get. Beyond that, though, there's no way of knowing if they chirped. We don't know what their soft tissues looked like because they, of course, don't fossilize. The soft tissues would be things like the vocal cords. The ancestors to dinosaurs were potentially mute. We don't know if they had vocal cords at that point. We know that crocodilians and birds, who are the ancestors of dinosaurs and the closest, closest living relatives, the closest living relatives have two very different types of sound-producing mechanisms within them. They evolved separately. So there's speculation, again, that perhaps different species of dinosaurs themselves evolved their inner apparatuses, again, differently than either of those two groups.
Oh, okay. So that means dinosaurs might not have really made any sound at all.
Potentially.
Really.
So another hypothesis for why they have those huge elaborate crests would be another type of communication. That'd be visual communication, because it's pretty striking, pretty unique to see this huge, weird looping thing on top of another dinosaur's head, and you'll say, "Oh, hey, that's Mom. I know that dinosaur." Or it could be striped or colored. We have no idea again what it looked like, but it's obviously for something.
Okay, that makes sense. So, but we won't really, can we, based upon the dimensions that we see in these, can we sort of speculate about how they might have sounded if we sort of discount the idea of soft tissues, or does that make any sense? Can we do that?
Sort of. We can look at the frequencies they produced. Again, we can calculate depending on how we... Okay, let's back this up. In physics, there's different ways of calculating what frequencies can be produced based on an error space.
I took this in music class.
Hey, well, there you go. So you know then that a short tube is going to produce a higher frequency than a longer tube, which will produce a very low frequency. And that... let's say we're looking at a recorder, those old-fashioned medieval instruments. Depending on where you put your fingers, it produces different harmonics. And now that's because it's based on the distance in the tube and how the air goes through it. It's math. And you can calculate from there then which sounds, which frequencies are going to be the loudest and the most pure. And you can then have an idea of which ones may have been the favorites of those dinosaurs based on the lengths of the air columns. And if you also then calculate in errors of soft tissue, you can have more variations even from then.
Okay, well, that makes sense. So you're prepared to do a demonstration based upon your research, what dinosaurs might have sounded like. I'm looking for some sort of cross-species sampling, so we'll need a couple of dinosaurs.
I'm not prepared to do that myself.
Okay.
However, it's fun to think of T-Rex sounding like just a giant chickadee, because it very well potentially could have had elaborate songs. We, again, don't know about those, but it's fun to think of those. In movies, they have huge roaring sounds. They have huge bellowing songs, but again, that's speculation. I'm not sure exactly what they would sound like, but
okay,
so
basically, using that, we sort of get a rough idea, and as best we know, they sort of it could have been chirps, or we really just don't.
Well, we really don't know, because the internal soft tissue apparatus will really vary what the sound will sound like.
Okay.
For example, we can't make sounds like birds because our vocal cords are so drastically different. We can mimic them, but they're never going to be the same. Same thing with crocodilians, the other close relative to the dinosaurs. They produce rumbling sorts of sounds that are transferred through their bodies in a very different way. Sometimes they can use their entire body, from what I understand, to help emit that sound, the rumbling, and they can hear through their sides a little bit. I don't know. That's again, another field that I might be making things up about.
That's cool. All right, cool. So, yeah.
Yeah, so hopefully eventually we'll build time machines and go back in time and record them and really
That's what I'm waiting for. That's obviously the second part of this article.
Well, yeah, obviously that's the second part of the research, is the time machine. But either way, if we do somehow find some sort of apparatus, fossilized remnant, then we'll have a better idea of how they made those sounds.
Thank you very much. I very much appreciate you coming on the show, talking to us about this. And, thank you, Della.
Thank you.
So we'll be going to our commercial break, and we'll be right back after that.
You are listening to Skeptically Speaking, thanks to the wonder of podcast technology or the generosity of one of our rebroadcasting stations. Skeptically Speaking is broadcast live out of CJSR 88.5 Edmonton, Alberta at 6 p.m. Mountain Time every Friday. If you're not in Edmonton, you can still listen to the broadcast live on our Ustream.tv feed, which you can find by following the Listen Live link on our website at skepticallyspeaking.com. You can also participate in the chat room and submit questions. During the week leading up to each show, you can find information on the upcoming episode and guest, and submit a question to be asked on the air. You can also subscribe to the podcast on iTunes. Our deepest thanks go to the stations that donate their valuable airtime to our program, including LP 99.1 FM in Madison, Wisconsin, Public Reality Radio WPRR 1680 AM in Grand Rapids, Michigan, Roslyn 101.1 in Roslyn, British Columbia, CJAI 92.1 Amherst Island Radio Broadcasting Inc., and on freethoughtradio.com. And now, back to the show.
Welcome back to Skeptically Speaking. This is Michael Harrison, filling in for Desiree Schell, and today we'll be talking about climate change. So we're here with Dr. John Gamon. We'll be talking, he's a professor and researcher at the University of Alberta. He's also a researcher for the TROPI-DRY Collaborative Research Network and co-founder of SpecNet. He studies the breathing of the planet, which is the exchanges of carbon and water vapor between the biosphere and the atmosphere that affect ecosystem productivity and help regulate our atmosphere and climate. And of particular interest are the effects of disturbance, fires, succession, weather events, and climate change on these basic processes. Welcome to Skeptically Speaking, John.
Well, thank you very much. It's a pleasure to be here.
So, first of all, I'd just like to break the ice a little bit. Tell us a little bit about yourself and what you do.
Well, by background, I'm a plant ecophysiologist, which means I'm trained in understanding how plants respond to physical environments, things like temperature and moisture. And more recently in my career, I've scaled that using techniques like remote sensing to try and understand how whole ecosystems respond to changing temperature, to changing moisture, disturbance events, and so on.
Okay. And so that ties in with your work at TROPI-DRY and with SpecNet.
It sure does.
Okay. Tell us actually a little about SpecNet. It's quite interesting.
Okay, SpecNet started as a group of scientists who share a common interest in understanding the role of the biosphere in the carbon cycle, how plants contribute to or take up atmospheric carbon dioxide, for example, through the processes of photosynthesis and respiration. And there's a need to understand that better, and one way is to measure it directly. The problem is we have a huge sampling problem. We can't sample the whole Earth, and the Earth is very big and very dynamic, and different parts of the Earth behave differently. Different ecosystems are different. So there's a need to use other techniques like remote sensing to view the whole Earth, but the challenge is how do we make a connection between what a satellite sees, let's say, and what we can measure on the ground. So that's where SpecNet comes in. SpecNet is a group of collaborating people who share a common interest in trying to understand how to use remote sensing to measure carbon exchange or water vapor exchange, the breathing of the planet. And a lot of what we do is we test different methods of optical sampling, for example, where we place sensors out on the ground or on automated systems, mobile platforms, and try and measure at a scale where we can understand what we're measuring, and then we try and compare that to the direct measurements, and we try and compare that to what the satellites see.
I'd like you to just sort of break the topic for us a little bit here. Just very simply, what is climate change?
Well, climate change is a pretty big topic.
Well, let's say global change, the one that the more recent one, because climate change could, of course, be previous climate changes. So we're talking about in our modern era. Okay.
Well, first of all, both climate change and global change have a long history, but if we're speaking about more recent times, during human times, we can look at how humans have influenced the climate or different regions of the world or different processes, Earth system processes. And so global change concerns itself with the whole sum of effects that cause the world to change, the Earth system to change, including the climate. And then the climate change refers really to one part of that, and that's the part we tend to hear about the most because we hear a lot about temperature changes, global warming, and things like that. So that's one aspect of climate change.
Okay. So there are a couple major branches of evidence that support basically modern climate change theory. Anthropogenic? Am I saying that right? Anthropogenic climate change. I found glaciers, vegetation, ice cores, dendroclimatology, pollen analysis, insects, and sea level change. So these are, I gather, the major pieces of evidence that we're using to put together our modern theories on climate change. What are these telling us about what's happening with the environment? Like, we know the glaciers are shrinking.
Well, you listed quite a number of things, and those are all important. And they measure or respond over different time scales. So when you put them all together, they can give us a bigger picture over a longer period of time than say, a thermometer can. So in addition to the things you mentioned, we have modern instruments, but a lot of the things you mentioned are also natural phenomena that we can use as indicators, or in some cases proxy records of how have things changed in the past, and we can then compare that to how they seem to be changing today, or how they are changing today. We are seeing some very dramatic changes in some of the things you mentioned, and ice, for example. There's parts of the world where the ice sheets seem to be changing rather dramatically, other parts where that's not the case. So we're learning a lot about the complexity of the Earth and how it works as a system. All of these are aspects of what's called Earth system science or global change research, and it's a work in progress.
That's definitely the impression that I get from the study. We're not entirely sure what conclusions to draw about some of the data, but it's just, or the impression that I have is just that it all sort of stacks in the same direction. Even if we're not quite sure what the interactions are, we're using those as it's just that it all sort of points one way at this point, from the rising of the oceans to, the levels that we see in ice cores, and of course, in the dendroclimatology, in the tree rings. It all basically points to increasing levels of atmospheric CO2 and everything, particularly in the last 30 years.
Well, to add to what you mentioned, we have direct records of changing atmospheric CO2 that are quite striking and show a human influence on the atmosphere. That's really the basis for a lot of our climate change today. And a lot of the things you mentioned are additional indicators that, taken all together, really tell us overwhelmingly that the climate is changing and humans are likely the cause.
Okay. So I'm just going to do a brief shout-out here. You can ask all your climate-related questions right here on Skeptically Speaking. If you want to give us a call at 780-492-2577, extension 1. You can email us live at skepticallyspeaking.com, or on Twitter, we're at Skeptical Radio. So I'd like to talk briefly, when you talk about global change or climate change, there's a lot of discussion of climate models. Just briefly, what is a climate model?
Okay, well, first of all, I should say I'm not a climatologist. I don't use climate models in my own work, so I have to say that up front. But a climate model is a fairly complex computer model that tries to capture processes in the atmosphere, and they typically break up the Earth's atmosphere into a series of cubes or grids and represent in each of those cubes or grids the concentration of different substances and the exchange of matter and energy between those different cubes in the atmosphere. And they're usually run on supercomputers, and they're often given starting conditions and then used to ask questions, what if we did this, or what if we had a different set of starting conditions, or what if we changed the atmospheric concentration in this way. And they're used to answer basic questions about how does the climate system work. They're part of the tools, one of the tools scientists use to understand the climate system. They're applied to understand past climates. If we can model a past climate successfully, then we have some confidence that we understand how the climate system works in these models. And they're also used as prognostic tools to try and ask what-if questions about the future. What if we don't rein in atmospheric CO2 concentration and it continues to go up? What would that lead to? That's a kind of question that a climate model can help address.
Okay. So there are, from my understanding, there are different climate models that represent different parts of the biosphere. And these are basically put together to try and generate an estimate or a picture of what we're trying to analyze. And but there would be different ones, like there might be several different models to model the same effect, right? And like that, and we might not be sure about which model to use in a particular situation, or some models might be appropriate for one situation as opposed to another. Is that more or less accurate, or?
Well, some of what you say is correct. First of all, they're not used so much to model the biosphere as they are to model the atmosphere.
Okay.
But
yes.
One of the differences between different climate models is it does have to do with the biosphere and the degree to which the biosphere is represented as a surface condition in the models. And historically, the climate models didn't consider the biosphere in any great detail. The newer climate models, some of them are starting to become very sophisticated in terms of how they represent the biosphere and the processes that go on within the biosphere. For example, the exchange of gases between the surface of the Earth, all that green stuff down there, and the atmosphere, processes like photosynthesis, respiration, evapotranspiration. So if you want a realistic prediction of climate or weather, it helps to try and represent processes, the important processes, realistically. And one of the things we've learned is that it's good to put some representation of the biosphere in these models, and models are increasingly doing that. But that's a relatively new phenomenon. I think historically it was thought that the climate was a physical process separate from the biological processes of the Earth, and we're learning more and more that these things affect each other. And so the different models have similar principles, but they incorporate these kinds of things to various degrees, depending on which model you're talking about.
Okay, all right, that makes a lot of sense. Now, your particular area of expertise in your bio is listed as the breathing planet. So you look at the biological effects of climate change and various other events on the biosphere and the way it interacts?
In a broad sense, you're right. That's a lot of what drives my interest in science, is trying to understand how does the biosphere respond to, for example, climate change or disturbance, whether that's natural or human-caused. Trying to understand those basic principles. I mean, it's sort of a fascinating thing when you look at a tree or you look at a landscape. You can't see this with your eyes, but it's actively doing things all the time, exchanging gases, affecting our atmosphere, affecting our climate in ways that are largely invisible to us. And so what we try and do is try and capture those processes and understand those processes.
Okay. Actually, we have a call here. It's Jackie from Edmonton.
I'm calling in and I'm asking, are hurricanes getting worse because of climate change?
That's a good question, Jackie. The prediction is that intense storms like hurricanes will get worse with warming. As you warm up the ocean, as the ocean gradually warms, it will tend to spawn more big hurricanes, storms like that. And the evidence is consistent with that, but the evidence is fairly recent, and because these kinds of storms often appear to have a certain random or stochastic behavior, they're a little bit hard to predict. I think scientists aren't entirely certain that what we've been seeing in terms of recent patterns are fitting what the predictions say, but they seem to be in some sense. So I think we can expect continued severe storms as we go into a future of a warmer ocean and a warmer atmosphere. And perhaps Hurricane Katrina is kind of a reminder of what the kind of storm we might be talking about. Now, whether or not that a particular hurricane like Katrina is a product of climate change or global warming, that's very hard to say. But in general, it's expected that those kinds of storms will increase in severity and frequency.
Well, and that's simply because it increases the amount of energy in the climate system, right? Like there's more precipitation and more heat in the system. Is that right? And basically, as a result, you will have more storms.
I think that's a pretty fair statement. Yes.
Okay. What I'd actually like to do, I just want to. You're of course familiar with the IPCC reports. I just wanted to sort of go over there's the fourth report that was released in 2007. There's another study being released, as I'm sure you're aware, that will be finished in 2012. But the 2007 results were pretty interesting. I just wanted to look very briefly at what they said. Basically, it said that world temperatures would rise between 1.1 and 6.4 degrees during the 21st century. Sea levels would probably rise between 18 and 59 centimeters. Both past and future anthropogenic carbon dioxide emissions will continue to contribute to global warming and sea level rise for more than a millennium. And last, global atmospheric concentrations of carbon dioxide, methane, and nitrous oxide have increased markedly as a result of human activity since 1750 and now exceed pre-industrial values of over the past 650,000 years. Now, as someone with knowledge of the field, does all that make sense to you? Does that
No, I think that's a pretty good summary of some of the material in the first volume of the fourth report. Bear in mind that there's a lot in those various fourth reports. And the first volume, the physical basis, does discuss those things you mentioned, and I think that's a pretty fair summary.
Okay. So, I mean, you're obviously familiar with the IPCC reports. Some people call these reports conservative. Some people call them radical. Do you feel it's more likely overstating or understating the case? Is there another reference that you prefer to go to, or do you think this is pretty much as good as it gets?
I think it's a really good starting point to get an overview of sort of what's considered the consensus view in science, to the extent that there is such a thing as a consensus view. I mean, scientists are notably skeptical. They tend to question evidence and question each other a lot. But here's a document that was put together by scientists from around the world and other people as well. It's an international effort, and it's an attempt to say, what do we really know and how much certainty do we have? And it's a pretty authoritative document, and it's a good starting point to try and learn about climate science, about global change, the human impact. I would definitely recommend it to anybody, particularly the summary document is a good starting point. Is it a radical or conservative document? That's an interesting set of terms. It's amazing that people do this, that people can take years out of their lives to get together and pull together a kind of consensus on something like this. So that's an extremely unusual thing. It's often called conservative in the sense that because it's a consensus document, a lot of the more extreme predictions or some of the more interesting aspects of science don't always get into this document. Mm-hmm. In other words, there's a lot of recent evidence that goes beyond what's been discussed in the report. Some of that starts to get in, but a lot of it doesn't fully make it in because something has to have been in the literature long enough for scientists to read it and to agree that this is most likely true. And so in that sense, it's a very conservative document, and that's one of the criticisms that some scientists have, is that it takes so long to go through this process that by the time it's been published, it's a little bit out of date, and it doesn't really accurately say, what we might know or what we might be learning. But I think in the fourth report we see some attempts to deal with that and to try and point to some directions where we might be headed, and it's a very difficult issue to stay up with the pace of science. But I do think it's an excellent effort, and I have to applaud the people who put a lot of work into this. Hundreds and hundreds of people put their efforts into this.
Okay.
But I should add, going to the actual scientific literature, the peer-reviewed scientific literature, is a place I like to go when I have further questions. And it's just a little harder to read if you're not familiar with the literature.
I wanted to talk. You were mentioning the scientific consensus, which is sort of the key to this particular issue. Now, if one pays attention to the media, one gets the distinct impression that there is not scientific consensus on this issue. That there is a significant other school of thought, and that there may even be some pressure by the scientific community to get people to toe sort of the ideological line on the global warming and climate change issue. Do you feel that is true? First of all, is there scientific consensus on the issue, in your opinion?
I do think that there is broad scientific consensus on some of the core issues discussed in the IPCC. If you actually read the report, there are a lot of things that go beyond those core issues, and they do talk about some of these peripheral issues, and the IPCC documents point out that there is less certainty about some of these other issues. So there would be less consensus on those issues. But around the core issues of, is the climate warming, and are humans the cause? I think the first point, the document, if I recall, calls that unequivocal, the evidence that
it does
the climate
actually
is warming.
Yeah.
And I think it makes a very strong statement that humans are the cause. But to put it another way, there's really no alternative explanation out there in the scientific literature that can explain what we see other than the human effect on the climate.
Okay. So, I mean,
talking about the current climate change that we're seeing now.
Absolutely.
As opposed to the past.
Okay. So really, there doesn't seem to be an alternative explanation for what we see everywhere, other than man-made climate change, or at least not one that has so far survived peer review.
I think that, that latter point, there is not an alternative hypothesis or theory that can really stand up to the test of peer review that provides an alternative explanation, besides the idea that humans are most likely the cause for the current climate warming and will continue to be for the foreseeable future. Now, as I mentioned, there are some areas that are less clear. For example, when you try and project into the future, there's a lot of problems with that. It's hard to predict the future. Nobody can do that. But using models and other tools, there's an attempt to do that. And I think that's an example of where there's less consensus. I think there's consensus that there will be further climate change. I think where there's some disagreement is on how fast will that happen and how severe will it be? What will the impacts be on humans, on biological systems, on our economy? That's where there's a lot more disagreement. And part of that disagreement comes in because it requires we understand human behavior, because what we do now affects the future, and we can't predict human behavior very well. At least I can't. So I think there are areas like that get quite interesting, and scientists probably disagree over some of those things. But again, over the main points, I think there's very little debate anymore. There's no serious scientific debate over those main points, that the climate is warming and humans are the cause.
Okay. Well, we will get right back to that after a short commercial break. On the next episode of Skeptically Speaking, a panel discussion on skepticism and race. Is the face of modern skepticism really as monochrome as it appears? How do we make our message appeal to a broader, more diverse audience? How do racial demographics influence belief in pseudoscience and the paranormal? Skepticism and Race, next week on Skeptically Speaking, Friday at 6 p.m. Mountain Time, live on CJSR and at skepticallyspeaking.com. Welcome back to Skeptically Speaking. This is Michael Harrison, filling in for Desiree Schell, and I'm here with Dr. John Gamon talking about climate change. If you wanted to get in on the discussion, you can give us a call at 780-492-2577, extension 1. Email us at live@skepticallyspeaking.com or via Twitter @skepticalradio. So, we were talking a little bit about the scientific consensus, the IPCC reports, and all that. I want to talk about something that there is a lot of public discussion about this, even with the state of science as it is. The counter arguments that are thrown out there, include natural variation, ocean currents, increased solar activity, cosmic rays. So you would have to say that, from a scientific perspective, these counter arguments don't really hold any weight.
I think in general that's true. Those are all important points that have been discussed for years in the scientific literature, and they're known to affect climate. One of the things that happens in the current IPCC report is they look at all those issues and they look at the human effect. And it's only when you include the human effect that you can really explain what we're seeing. You take that out, and all those natural factors currently aren't having much of an effect on our climate. You got to realize that humans have existed as a civilization. Our civilization, our much of our recorded human history has occurred during a period of relatively stable climate, and what we're seeing now is the beginnings of a very different climate. The beginnings of we're headed on a different trajectory, and that new trajectory can only be explained right now by the human effect. And those natural events are not consistent with the current trends. Even though those are important parts of the models, they've been important in the distant past, and they continue to affect our climate.
Okay. Because, frequently what will come up during these discussions are things like the Little Ice Age or the medieval warming period, right? Which are obviously examples of where the climate changed. And in those cases we know it wasn't really from human interference. So
Sure.
It's different this time because of the gas levels in the atmosphere, or
Well, it's different for a number of reasons. We have a very clear record now that the CO2 levels and other gases are reaching levels they've never been throughout the hundreds of thousands of years. And this, on first principle, should change our climate. The changes that we're seeing in climate are consistent with those principles. And we're seeing all kinds of responses in the natural systems, ranging from ice sheets to biological responses that are consistent with something new afoot in the climate system. And yes, there's been change in the past. Some of those changes we understand. Some of them we don't fully understand. But what we're seeing now seems to be markedly different.
Okay. So back to a little bit about how basically how this information interacts with the political sphere. Some people really are under the distinct impression, for which I blame the media, that through peer-reviewed journals, people are, if they're presenting alternate takes, that they're really being forced out of the scientific body, that it's just not really acceptable to discuss alternative means. But of course it is mentioned in the IPCC report, as you mentioned, and I think that there is openness to research on these on other theories, but I'd just like to hear you respond to that. Like, do you feel that there is that people are discouraged, that scientists are discouraged from looking into other alternatives?
So I'm sure that some of that happens. I think that issue in general is overblown, but one of the problems that happens with science when it's in the public eye and it becomes politicized, or there's a lot of political pressure to bear on science, is that pressure tends to distort the process of science, which by itself is based on evidence. It's based on a series of methods for evaluating evidence. And in principle, there's no reason why someone should present contradictory evidence, and they should be able to do that through the peer-reviewed system and get things published, provided they have support for their evidence. And that does happen all the time in science. So I don't think there's this vast conspiracy to try and get rid of other opinions through the scientific process. I think the scientific process works relatively well most of the time. But when you start to distort that process through other means, how you fund science, or through death threats on scientists, or other extreme things that happen as a result of the public discussion around these issues, then I think that does affect science, and it's not always good. I wouldn't be surprised if some people respond badly to that sort of thing. If you're in the middle of that kind of political debate, it's very hard to have a fair evaluation of evidence and a fair discussion, on which science really thrives. So I think there are some problems, but I don't see a real problem among the scientific community trying to choose what gets published and what doesn't. I think that system basically works the way it's supposed to.
Okay, so you think that that the internal debate within the scientific community adequately represents, all sides and all approaches to this at this point, or at least as well as it can be expected to.
I think it does that really reasonably well. I'm sure there's some examples where it could work better. I'm sure
Absolutely.
We could improve the system. I think we need to look at that all the time. And I think scientists constantly criticize the system, the peer review system, and each other. And that's part of how it gets better. So I think there are some things we can do to improve science and how we do science.
Okay. So given that there is such a vocal and obviously apparent public debate on the issue, what does the average person who's working in the field, or at least knowledgeable of the field, think of the arguments that are espoused against the scientific consensus on this issue? I mean, we don't have to look far to see some interview program somewhere that is balancing off someone who knows something about climate science with someone who is for lack of a better term, a climate skeptic. Do you feel that those discussions adequately represent reality, or that good things are brought up by that process, or is it just really propping up the debate?
I think that's propping up the debate. There's this tendency in the media to present both sides of the issue, partly in the interest of fairness, which is a good idea, but also it makes a more interesting show to have opposite points of view and to have people getting into heated discussions or arguing. It's a bit more entertaining. Well, here I think entertainment shouldn't be our only goal. I think informing people accurately is important. And with this particular issue, with the core issues we've discussed, is the climate changing and are humans the cause? There's not a big scientific debate, so why present that as a debate among scientists? Why present opposite points of view when, for the most part, there's no controversy over those core issues? It makes sense maybe to discuss some of the other issues that are more peripheral, but we seem to keep coming back to these core issues and this false debate, this false controversy, and it's pretty much, I find that very discouraging, and I'd like to think we're past that, and that I think a lot of the media is very responsible in how they report on this, but I think there's still the tendency to try and produce somebody on an opposite side when there is no opposite side. I also think that these arguments against climate change sometimes are old arguments that have been dealt with in the science, and they're taken out of context and they're no longer relevant. If you read the literature, you'll see that they've been addressed. And so a lot of those keep cropping up, and it's very frustrating as a scientist to see people discussing those as if that's a legitimate current issue when it's not anymore. So what it tells me is scientists could do a better job about informing the public. I think we try to, but sometimes that's not where our training is usually. We're not trained to speak to the public. We're not trained to deal with the media. We're not trained to do all those things. So I think we could do a better job of getting the message out. And there's an awful lot of scientists who are trying to do this. And I think that's in part what the IPCC report represents, is an attempt by a huge portion of the scientific community to document what the scientific literature actually says about these topics. So, most of these issues really are non-issues that you hear in these controversy. They're red herrings. They're things that are old issues. So it's frustrating sometimes, but I guess that's the way it is.
If I could ask, what is the worst example of misinformation on this subject that you've seen or that comes to mind? I've seen quite a few. That the Great Global Warming Swindle movie was full of all kinds of information about solar cycles and everything that seemed very, very credible until you actually looked at the underlying evidence. And some of those are maybe credible in isolation, but when you put them together with other things, those arguments don't hold any water. They can't explain what we're seeing now in climate, for example. So something that might have explained the distant past can't be applied to the present or the future unless there's evidence to do that. And, I would ask, where's the evidence for some of these things? These arguments often don't present it. But in terms of your question, for me, one of the extreme things that I see a lot is a statement that there's some kind of vast scientific conspiracy out there trying to adjust change the message or control the message. I mean, to me, that's absolutely ludicrous because scientists have trouble agreeing on anything. And it's sort of like herding cats, trying to get a bunch of scientists to agree on things. I work with scientists, and it's amazing where you can get a lot of people to have a consensus on anything. So this concept of this vast conspiracy, scientists are somehow getting together around the world, and from all over the world they're secretly agreeing to cook the books or to somehow make up some false theory is absolutely absurd. But we keep hearing that. We do keep hearing that. I always thought it implied an absurdly high level of organization. But
that's true. And it may be happening on the other side. I think there's a bit of that does happen, but I don't think it's within the scientific community.
Fair enough. We actually have a caller, Tina from Edmonton. Go ahead.
Are there other contributing factors to climate change besides humans?
Oh, yes. That's a really good question. Yes, there are. And if we're just looking at the current climate, recent trends in the last few decades and where we seem to be heading, there is evidence that other factors do affect climate, and if you take them all together, they have a negligible effect in climate, and the climate should be fairly stable. But if you add the human part, then suddenly you can explain why things are actually changing in the direction that they are. So all those factors are important, and they're part of what changes the climate, but in a much smaller way, and in balance they don't have much of a net effect on the current climate from our best understanding. Humans seem to be the primary cause of the current climate change.
Okay. We actually have another call. Navita, also from Edmonton. Hello, go ahead.
I have a question. The CO2 levels have been decreasing since 1985. Why is that?
I'm not sure what you're talking about. Are you talking about atmospheric CO2 or some other kind of CO2?
Oh, no, the atmosphere.
Well, if it's atmospheric CO2, the levels are actually increasing and have been since the measurements began. And that's a human effect, largely. So
that is what it says in that little section I was reading from the IPCC report. That is what it says. It says that it has increased as a result of human activities. It's since 1750 now far exceed pre-industrial values from over the last 650,000 years. So it would seem that they are higher than they had been before, at least according to the IPCC.
Yeah, what we're basically doing is injecting a whole lot of CO2 very fast into the atmosphere, and it's starting to change the system.
Okay. Again, if you have anyone else having questions about climate change or anything related, our phone number here is 780-492-2577, extension 1. By email, you can reach us at live@skepticallyspeaking.com or via Twitter @skepticalradio. I have a couple other questions here. These are ones that were sent in. Can we assume the Earth's hydrosphere and atmosphere are warming to what we think may become a dangerous degree, and accept that human activity may be a contributing cause, and yet be skeptical of the popular and political responses to this assumed warning? How do we separate the best evidence from the hype, filter out the hyperbole, and develop a practical individual action plan?
Well, that's a big question. It's actually a whole series of questions, and it's hard to take it in total, but I would suggest to anybody who's out there that if you haven't already done it, read the IPCC report. It's online. It's free. You can search for IPCC, read the fourth assessment report, read the summary to start with. It's fairly short, fairly to the point, and it really covers some part of that question. I'm not sure I completely understood the part about the political or the other aspect of the discussion. In the middle of the question,
I think they were. I think what they're trying to get at is that even if they're if they're agreeing with the scientific consensus on this, they don't necessarily agree with the political responses to the problem, which I think is something a lot of people could identify with. I'm not necessarily sure that's something you can answer, though.
Well, yes, I mean this is getting into matters of opinion. And the IPCC report, the other volumes beyond the first volume do talk about issues of impacts and adaptation and mitigation. And this is where you start to talk about the human effect or the human impacts. And this is also part of what comes up in, I think, our popular and political discussions is how do we respond? How should we respond? What policies should we be adopting? What is the role of government in these issues? How do our institutions deal with this issue? Are they dealing adequately or not? Are they over-responding, under-responding? That's a complicated issue. I think, in my view, how the political discussion goes, how we translate science into some sort of meaningful political discussion is a very difficult challenge, and I think we need to work on that whole issue. And how our institutions, our human institutions, our political institutions respond to science is a whole other problem. And I don't think we're very good at quickly learning from science and adopting new policies. There's times in history where we've done fairly well, and there's times when we do very poorly. The political process and the discussion around that doesn't always quickly get us to a solution. So I'm not sure what the questioner intended with that, but those are some of my comments.
No, I thought that was excellent. I mean, I don't know that you could give a definitive answer on that particular question. It is a bit vague, but thank you.
Well, part of the question also dealt with how do we figure out the evidence from the hype. I mean, the scientific evidence is largely out there. It's a bit hard to sift through, and there's a lot of it. But the IPCC report does a good job of summarizing that. So that's why I think people should read it. Hyperbole, well, listen to who's talking. Are they a practicing scientist? Do they actually have the credentials to talk about what they're saying? A lot of the hyperbole that I hear is coming from people who know nothing about climate science or global change research, and they're speaking from dogma or faith or some other issue, some other perspective. Is the speaker able to look at the evidence or not? What is their perspective? That's an important thing to know. And I think there's a lot of things that individuals can do in terms of action plans. At a larger level, the IPCC report talks about this in terms of mitigation, sort of more at a policy level. But a lot of people look at making changes in their lives in response to what we're learning about climate change. And I think there's a lot that we can do as individuals.
Okay. So we actually have another question that was emailed in to us.
The question is, if we stopped everything right now, can we make any guess as to how much damage has been done already?
Yes, I think we can. And again, the IPCC report goes into that. One way to think of it is what we've already done is going to have effects far into the future for hundreds of years because, for example, a lot of the gases we're putting into the atmosphere sit there for a long, long time. And it takes a long, long time to warm the ocean because it has a high heat capacity. It's very large. So we have not seen the full effect of what we've already done to the atmosphere. We've just seen the beginnings of that, the tip of the iceberg. So I think this is one of the causes for alarm among scientists is that when you look at how the Earth works as a system, it takes a long time to see the full effects of these kinds of perturbations to the climate system. So I do think that we've already started on something that is taking us in a new direction, and it makes sense to look at that and to try to rein in what we can and to really head in a better direction if we can.
Okay. I have another sort of a similar question here. It was also sent in. Who is telling the truth, and how will I know when I see it? When one reads about the leaked emails and the documents from the Climatic Research Unit at East Anglia, it is tempting to think that someone cooked the books. Ice core data and tree ring research from Russian researchers appears to have been massaged to support popular foregone conclusions. If it walks like a duck and quacks like a duck, might it be a duck? That's
an interesting question.
Yeah. Go ahead.
I think on the face of it, this what's called ClimateGate now, this hacking incident where somebody broke into climate researchers' emails. And when you take those emails out of context and present them with a particular agenda, which is the science, the agenda seems to be the scientists are not being honest. I mean, it's easy to believe that, and I don't know the truth of that issue. I'm looking forward to the outcome of investigations that might help clear up some of this. But I think it points to some problems with science and with climate science. One is it is a complex issue, and how do you take the data that scientists work with and draw conclusions from that, and then how do you translate that into things that the public can understand, and how do you do that with enough transparency that people can trust every step along the way? And I don't think we have enough of that transparency in science, and one of the things that concerns me, and I think one of the things that a lot of scientists are aware of with this issue, is that we need to be more transparent with what we do. I'm not saying that the people there did anything wrong, the scientists there. I don't know. I don't think the evidence is fully in yet. I think some of the arguments in the political discussion that I've heard seem rather ridiculous. I don't think it changes the conclusion of the scientific community about the basic science in any major way. Putting together these different records is quite difficult, and at its heart, this issue of this incident has to do with how the scientists dealt with the data. And from what I've read, there's nothing to tell me that they've done anything seriously wrong here, but these are complex data sets. it's interesting that this question comes up because the class I'm teaching with Dr. Christian Haas, we're having the students look at that exact issue and go back to the data and try and reconstruct what they can from the actual original data sources. And we'll see what we learn from it. So I think that's a good example of where the political discussion and people with an agenda come in with a preconceived agenda and try and do a lot of damage to the process of science. And it's not to say that science couldn't be improved in terms of its transparency, but I don't think it changes the core conclusions about the science. And so to answer the question, how do you know? Well, I would see who's making the statements again. What are their credentials? And do you believe somebody who doesn't really present their identity, whoever is behind the hacking, or do you believe a scientist who's been in the peer-reviewed literature for decades? That's a choice that individuals have to make. Personally, I tend to believe the people who I can follow and who I can read what they've said if I agree with it. And so I think in that particular incident, we're going to learn a lot more as time goes on. And it'd be interesting to know what was behind the hacking incident, who paid for it, and why. But I don't know if we'll ever find that out.
Yeah, no, it would be nice to know. We're running pretty close to the end of our time here. I'd like to just ask you if there was something that you wanted to say to people that were interested in this subject and maybe just weren't really sure what to think. What would you say to them? What would be one piece of advice you would give to them? Would it be to go back to the IPCC reports and the research?
I think that's always a good idea. That's how science works, and so I'm a scientist, so I would be tempted to say, look at what scientists actually do. Try and get familiar with that. Start with something like the IPCC report, because it's free, it's available. Look at the scientific literature. Look at how science works. Spend some time with it and learn what scientists actually do. And science is one of the most exciting things that people do. It's really interesting and really fun. And so I always think it's good to look at science and how it works. It's always interesting. And I think, for individuals, follow your interest. To some people, this takes them to science. Some people takes them to politics, and they become active on behalf of science. Some people become interested in things in their personal lives. I've worked with religious communities, for example, where people see spiritual issues in these topics, and they get very interested in these issues and try and do things through faith-based communities. So there's a lot of individual responses that are appropriate, I think, to the things that we're seeing in the times that we live in.
Okay.
Those are some suggestions.
And thank you for them. So we are out of time. Thank you so much for being with us today, John. And
it's a pleasure. Always a pleasure to talk about science.
Yes, and it's a pleasure to hear from you. Thank you. That is it for Skeptically Speaking for today. You can find details on everything else about the show at skepticallyspeaking.com, including a link to the Facebook page and iTunes where you can subscribe to the show. Thank you for listening, and we'll see you next week on Skeptically Speaking.
South America does not exist. The moon is painted on the sky. Things sometimes fall up, but you never see. And everything you believe is a lie.
Dinosaurs were invented by God as a test. Our bodies don't rot when we die. Oh, the hippies are working for the government, and everything you believe is a lie. you.